This Unit 7 that I'm beginning depends upon this lesson. So in other words, the entire unit is going to build upon this lesson. If you don't know the properties of quadrilaterals, you will be lost throughout the entire unit in different contexts, because we're going to be doing algebra with this. We're going to be doing regular Euclidean geometry proofs, and we're going to be doing coordinate geometry proofs. All right, so with that said, let's start with what a quadrilateral is. Okay, so a quadrilateral is simply a four-sided polygon. Doesn't have to be anything special about it. Okay, that is a quadrilateral. It always has 360 degrees inside because you can make two distinct triangles that are non-overlapping, right? Anyway, that is a quadrilateral. Okay, these two segments, just an FYI, AC and BD, are called diagonals. So what diagonals do is they connect non-consecutive vertices. B and C are consecutive. A side would connect them. So what a diagonal is, it's a segment in a polygon connecting non-consecutive vertices. Because consecutive would be sides, kids. Hold on. Put an extra C in vertices. All right. So there's nothing special about a quadrilateral other than that there's four sides. Okay, there's 360 degrees inside a quadrilateral. All right. Now, when we take a quadrilateral and we make one pair of opposite sides parallel, just one pair, we call that a trapezoid. Now, we could make a trapezoid something more specific, right? But a trapezoid, okay, the general definition is a quadrilateral with at least, okay, at least is dangerous, at least one pair of opposite sides parallel. So typically you're used to it looking something like this. These sides would be parallel, AB, CD. Now be careful though, it could have two pairs of sides parallel. It could, and then it would be a parallelogram. I'm just going to draw it the way that you're used to seeing it. Now, what does this mean for us? Well, let me just extend these lines, right? These are parallel lines, okay? They're cut by transversals. Here's one transversal. Here's another transversal. Okay, these angles, I'll call this X and Y, and then we'll call this WV. So in between parallel lines, same side interior angles are supplementary, right? So angle X and angle Y are supplementary. Same thing with angle W and angle V. Okay, that's really all you can assume from this. And the reason for this is because you have parallel lines, same side interior angles are supplementary. All right, so now we can have a more specific type of trapezoid, something called an isosceles trapezoid. Now I'm going to do the most general definition, but it could be more specialized. So an isosceles trapezoid is a trapezoid with the non-parallel, this is assuming they're non-parallel, congruent. Okay, but they could be parallel with the non-parallel sides, okay, if they're non-parallel, which they usually are, okay, but you just have to be careful because trapezoids could be parallelograms. So an isosceles trapezoid, you would have, okay, these two non-parallel sides would be congruent. So the significance behind an isosceles trapezoid is that when these sides are congruent, that makes these angles congruent at the bottom and these angles congruent at the top. Okay, these are called legs. These are called bases. Base 1, base 2. And the real significance comes in the diagonals being congruent. Diagonals are congruent. Okay, that is an isosceles trapezoid. Now we're going to move on to the parallelogram. So the definition of a parallelogram is a quadrilateral with two pairs of parallel sides. Okay, so what this means for us, just a note, all parallelograms are trapezoids because they have the characteristics, okay? Only some trapezoids are parallelograms. All right, so just keep that in mind. It's rare that it comes up, but it could confuse you. Okay, so for a parallelogram, you're just going to have two pairs of parallel sides. Okay, so that's what it's going to look like. Now, because of the shape, because of these two pairs of parallel sides, we have other properties that exist. All right, so let's look at the properties of a parallelogram. You're going to have to memorize these, okay? So the properties of a parallelogram, both pairs of opposite sides are parallel. That's number one. So what this does by having this, it cuts off equal distances, so both pairs of opposite sides are congruent. Then we end up having, well, always consecutive angles are going to be supplementary, okay, in all parallelograms. because think about it, you have same side interior. Consecutive angles are supplementary. Opposite angles are congruent. Okay. One of the most important characteristics is that the diagonals bisect each other. Okay, so that's very important because that does not happen in a trapezoid that is not a parallelogram. Now keep in mind, a parallelogram can shift into a more specific quadrilateral. All right, so there are other quadrilaterals which are parallelograms, but only some parallelograms will turn and shift into those shapes, all right, depending on the situation. So, in other words, let's say we take this parallelogram and we straighten it out. By straighten it out, I'm saying that we turn all the angles into right angles. Now, when you look at this, you know that this is a rectangle. So the definition of a rectangle is a quadrilateral with 4 right angles. Okay, now take note, the less specific quadrilaterals are rectangles. Okay, so all trapezoids, the more specific is the less specific. So all rectangles are trapezoids. Okay, but only some trapezoids are rectangles. All rectangles are parallelograms. Okay, all rectangles are isosceles trapezoids. Now, what's interesting about this statement is that not all parallelograms are isosceles trapezoids. Okay, so that's kind of interesting. So when you have a rectangle, the properties, let's look at the properties of a rectangle. Okay, number one, you will have all the properties of a parallelogram. You can write parallelogram like this with a little p in the middle. So you have all those properties. So automatically opposite sides are congruent. Opposite sides are parallel. Okay, both sets. Diagonals still bisect one another. Consecutive angles are still supplementary because they're all 90 degrees, right? So all of those properties are still going to be intact. That's not a problem. But you're going to have additional properties. So let's draw a rectangle. Okay. All properties of a parallelogram plus congruent diagonals. This one's extremely important. This is going to come up all the time. Congruent diagonals, okay? 4 right angles. You only need to prove that you have one. If you have a parallelogram with 1 right triangle, okay, is a rectangle, no matter what. Okay, however, that's not going to be the case with a trapezoid. We could have a trapezoid like this. Okay, that is certainly not a rectangle. So a trapezoid with a right angle is not guaranteed to be a rectangle. But a parallelogram with a right angle is. Okay, so a trapezoid with a right angle is not necessarily a rectangle. Why do I say not necessarily? Well, because what if it were an isosceles trapezoid, right? If it were an isosceles trapezoid with right angles, then that would become a rectangle. Okay, that's getting a little too specific, but I'll write it down anyway. An isosceles trapezoid with a right angle will be a rectangle. Okay, don't really ever see that one coming up, but I also have to teach to the kids in here, okay, that want to know this theory. So you have 4 right angles and you have congruent diagonals. Okay, next we're going to look at the square. All right, I mean the rhombus, sorry, getting ahead of myself. So let's look at the rhombus. So a rhombus is any quadrilateral with all 4 sides having equal length. So that means all 4 sides are congruent, all right? So a rhombus, okay, all rhombi is plural for rhombus. You could say rhombuses as well. All rhombi are parallelograms as well. Now, not all rhombi are rectangles. Not all rectangles are rhombi. So be careful with that. All right, they basically, rhombi and rectangles live on their own. When they get married, that's when we're going to have a square, okay, when they combine. So anyway, so what are the properties of a rhombus? Well, I just said one, all 4 sides are congruent, right? So number 1, you have all the properties of a parallelogram. Now, it's going to seem silly. Both pairs of opposite sides are congruent when all 4 sides are congruent. The one just supersedes the other, okay? If all 4 sides are congruent, then both pairs of opposite sides are congruent. So you have all the properties of the parallelogram. Diagonals bisect one another. Opposite angles congruent, right? Opposite sides parallel. All that. Plus, let's look at a picture of it. Okay, one of the most important things that you have is that the diagonals bisect the angles. So if you look at angle A and angle C, okay, they're going to be bisected. Same thing with B and D. They'll be bisected. Now, because not all rhombi are rectangles, we're not going to say that the diagonals are congruent. If they are, then the rhombus shifts into a square because it straightens out. We're also not going to assume that the angles are right. That doesn't mean that they're not, okay, but they could be. Okay, but for the most part, most rhombuses or rhombi do not have right angles. One of the most significant things besides the diagonals bisecting the angles, right, and all 4 sides being congruent, is that the diagonals are perpendicular. So be careful with this one. You're going to be using the Pythagorean theorem a lot. Anytime you have a right angle, that could come up. And depending on the right triangle, special right triangles could come up in this as well. So those are properties of a rhombus. The last shape that we have, okay, is the square. So let's look at a square. So a square is both a rectangle and it's a rhombus. So everything's going to be true for a square. So number one, all squares are obviously quadrilaterals, right? All squares are trapezoids because you have the properties of a trapezoid. All squares are isosceles trapezoids. All squares are parallelograms. All squares are rectangles. And all squares are rhombi. Okay, kids, so what this means about a square is you go through the properties, it's good review. List all the properties of the parallelogram. List all the properties of the rectangle, all the properties of the rhombus, and there you have the properties of a square. Okay, we'll be continuing this in class. This is a good introduction to the unit. This is material that you're going to have mastered in order to succeed, okay? I will leave off, all right, by making a family tree. We'll end there. Lots of times people start with that, but if I do that and you don't know the properties, it seems kind of irrelevant to me, all right? So you have a quadrilateral. A quadrilateral could be possibly a trapezoid, right? Now, that trapezoid could possibly be an isosceles trapezoid. It could also be a parallelogram. Now, this is going to get a little dicey here, okay? When you have an isosceles trapezoid, okay, can turn into a rectangle. But so can a parallelogram. It's just, it turns into it differently. With an isosceles trapezoid, sure, you get the right angle, right? Parallelogram as well. Okay, but they're different shapes turning into a rectangle. So you could have a rectangle. Parallelogram could also turn into a rhombus. And then at the bottom of the family tree, a rectangle and a rhombus can turn into a square separately. So you can follow any one of these pathways, okay? But if you look at the bottom of the tree, all squares are rectangles, or all squares are rhombi, all squares are isosceles trapezoids, all squares are parallelograms, all squares are trapezoids, all squares are quadrilaterals. Follow the rectangle up. All rectangles are isosceles trapezoids. All rectangles are parallelograms. All rectangles are trapezoids. All rectangles are quadrilaterals. All parallelograms are trapezoids. All parallelograms are quadrilaterals. All rhombi are parallelograms. All rhombi are trapezoids. All rhombi are quadrilaterals. You get the idea? Okay, but now, if you go from the top of the family tree down, you can morph into other shapes. Okay, be creative with it. So a quadrilateral can morph into a trapezoid. That can then morph into an isosceles trapezoid or a parallelogram. So some trapezoids are isosceles. Some trapezoids are parallelograms. Then an isosceles trapezoid can morph into a rectangle, right? some isosceles trapezoids are rectangles. So it's under the proper circumstances that that will happen. All right, so hopefully this will help you. This logic is extremely important for when we do proofs. Okay, kids, see you in class.